I will be speaking about our recent examination of seasonality, bait type, and survey design on capture efficacy of Spilogale interrupta. Prior to the study group, there was a lack of historical information on best survey techniques for plains spotted skunks. Crabb reported on ease of capture among a myriad of additional ecological associations from a population and habitat type that is now gone from southeastern Iowa. Our colleagues from Missouri used three different techniques in Arkansas and Missouri in the early aughts. While their efforts yielded many captures and individual skunks, the effort to reach these results was immense. More recently, Blake found that historical fur trappers were using intuition and experience to either intentionally or incidentally trap spotted skunks. There are major issues here concerning proper study design, such as how do new researchers gain this experience and intuition to identify suitable trapping locations, and how can we utilize these historical results to inform current survey design? Crabb and Hackett both reported a decrease in summer capture rates. These results have impacted survey design ever since. To throw the first stone, during our 2015 and 16 survey of Texas, we did not survey or trap during the summer. Additionally, many projects have either not surveyed during the summer or reduced efforts during the summer. This is very questionable design. Is it wise to base survey design on these previous reports? Are we biasing results by not surveying in the summer? But maybe the most important question is, are we unwisely using our summer labor by not trapping during the summer? Mesocarnivore trapping success can be impacted by the use of bait, bait type, and the addition of lure. Historically, fur trappers used a variety of baits including birds, various small mammals, and bloody meat. Recently, researchers have used canned fish or pet foods. Additionally, Chuck has his own secret blend that is very successful in the Northeast. Is there a best bait, or do spotted skunks exhibit generalist behavior and can be captured effectively by a wide variety of baits? Currently, most states have initiated population monitoring, and some may be moving towards population management where warranted. With this in mind, it is incumbent to record a representative sex ratio for proper monitoring and management of our local populations, regardless of what that ratio is. With the extensive history of reported male bias ratios, we have to honestly ask ourselves, is this bias from survey design, or is this the result of higher mortality rates in females? Our overall objectives for this research were based on a spatial ecology project that necessitated we capture, collar, and monitor a representative sample of our local population. For this manuscript, we assessed seasonality and bait type on capture efficacy. Additionally, we assessed the sex ratio of skunks captured by systematic survey design compared to the sex ratio of those captured by casual survey design. Our study site was in southeast Texas within the Houston metropolitan area. Specifically, we surveyed the Katy Prairie, a northern extent of the western Gulf coastal plain. The property is co-owned by both the Katy Prairie Conservancy and the Warren family. KPC works to conserve the native prairie as well as the historical land usage of this area. The result is a mosaic of pasture types, including minimally grazed native prairie, winter forage, hay pastures, and heavily grazed native summer forage at Warren Ranch. At the pasture level, camera traps were used to locate presence and inform live trap survey locations. Post-detection, we overlaid a 100-meter grid over the entirety of the pasture and deployed a single live trap at each node. Trapping surveys were 5 days in length. This was a logistical design based on our weekly tracking and camera trap schedule. Individual traps were baited with either mackerel or sweet bait, which was a modified version of Chuck's own. Suitable individuals were affixed with a GPS transmitter. All of the standard measurements and samples were taken, and the skunks were allowed to release from traps modified to allow egress, but not ingress, of larger mesocarnivores. Our casual methods were based upon a survey of the site in 2016 that resulted in 3 unique skunks captured in 7 days. When we first deployed traps in February 2019, we chose the pastures that were visually similar to the pastures with 2016 captures. Traps were arrayed as transects, either internal or 25 meters from the edge. We used mackerel only. The traps were placed 100 meters apart, and survey lengths varied between 2 and 8 days. For systematic surveys, trapping results were compiled for each survey night. We examined capture efficacy among the seasons and between the 2 bait types. Additionally, we examined our a priori hypothesis that capture rates would be lower during the summer. These variables were all analyzed by a general linear model with a binomial error term. Additionally, we first analyzed whether individual pastures or inoperable traps due to non-target captures influence capture rates. Analysis indicated that neither of these variables influence capture rates, so they were not accounted for when examining seasonality and bait type. Additional information is available in our publication in the Southeastern Naturalist special issue. To examine effects of survey design on sex ratio of captured skunks, we compiled the ratio of all captures between the 2 survey designs and analyzed by a chi-square test of independence. Through 20 months of trapping, we captured 29 individuals 49 times. Skunks were captured in all seasons, with both bait types and with both survey designs. I want to note that from all captures, not just what is presented here today, we only captured a single predispersal juvenile. From summer 2019 through summer 2020, we conducted 22 surveys in 12 pastures, resulting in 3,100 trap nights. 32% of these surveys resulted in 0 captures, and 68 resulted in at least 1 capture. We captured 23 unique skunks 30 times at the approximate capture rate of 1 per every 100 trap nights. Our observed sex ratio over these 30 captures was 1:1. Removal of the recaptures resulted in a slight female bias. We had relatively even survey effort and capture rates other than summer 2020, which had the least effort and lowest capture rate. When results were averaged across both years, this resulted in a summer capture rate that was slightly higher than our overall capture rate. Analysis indicated that seasonality did not affect capture efficacy, and a test of the a priori hypothesis that capture rates would decrease during summer indicated that summer capture efficacy was comparable to the other 3 seasons. We observed higher capture frequency with mackerel compared to sweet bait. Removal of recaptures from the dataset to remove influences of behavioral modification resulted in a slightly higher rate of capture with mackerel. However, this subset was not analyzed due to the small sample size. Analysis indicated that our capture efficacy was not affected by bait type. However, we believe that we observed a biological effect, and failure to show this was due to a lack of power. We conducted 17 casual surveys in winter, spring, and fall 2019. Over approximately 2,000 trap nights, we captured 8 male skunks 19 times. The left column reiterates the results from the 2 survey types, which show a 1:1 sex ratio for the systematic surveys and a 19:0 male bias for casual surveys. Our systematic survey design was more effective, at capturing female skunks than our casual survey design. At project initiation, we emphatically decided to not conduct exhaustive live trapping surveys. Unfortunately, we were forced into the systematic trapping surveys due to insufficient results from our casual surveys. Two caveats are that insufficient labor and standing water during winter and spring 2019 likely impacted our casual survey results. The matrix at our site was a mixture of quality, suitable, and uninhabited pastures. All systematic surveys were conducted within either quality or suitable pastures. Within quality pastures, we observed high densities, overlapping home ranges, and a fidelity to the pasture outside of breeding season. Compared to our transect arrays, our grid arrays increased the number of traps deployed per pasture, the number deployed within an individual skunk's home range, and the likelihood of deploying traps in the home range of all skunks that inhabited individual pastures. Our grid arrays led to more efficient sampling. However, within individual pastures, we knowingly deployed traps and habitat types that GPS data indicated the skunks were avoiding. Additionally, we know from the cameras at the release traps that we did not achieve 100% capture rate in individual pastures. In the future, it may be advantageous to not survey these avoided areas and increase survey lengths beyond 5 days. Additionally, this survey design is possibly not replicable in mountain habitats, and the results may be different for locations with lower population densities. Previous reports indicated seasonal capture efficacy decreased in summer for multiple spotted skunk species. However, we observed no difference between seasonal capture efficacy. While this is the first report of similar seasonal capture rates in Plains Spotted Skunks, Harris et al. Recently reported similar results from Florida spotted skunks. Our results could be influenced by the habitat matrix at our study site, and specifically the uninhabited pastures, which created barriers to movement. Additionally, our systematic techniques resulted in more females captured during summer than the other 3 seasons combined. It is possible that the energy cost of gestation, parturition, nursing, and food provisioning increased susceptibility of female skunks to trapping. We can't untangle the influence of individual variables from our overall results. However, we feel that the grid array and summer surveys more efficiently allowed us to capture females than the other aspects of our systematic survey design. Only a previous report arrayed traps in a grid and surveyed during the summer. Authors reported a female bias from this population. While Hackett et al. Reported relatively even sex ratios, the survey effort was 5 times our own with a similar number of unique skunks captured. We observed higher, albeit non-significant capture success with mackerel versus sweet bait, indicating both baits were effective with mackerel being the most. However, we proposed that additional data collection would have shown mackerel was more effective than sweetbait. To wit, we continued systematic surveys through fall 2020 with verbatim results. In winter 2021, we actually dropped the sweetbait from our surveys. My final recommendations are this. Design and conduct camera trap surveys based on established methodology to locate presence. Conduct follow-up grid-based trapping arrays with traps thoroughly dispersed throughout the area of detection. Conduct trapping surveys in all 4 seasons. And finally, use a fish-based bait and an alternate bait that does not have significant rodent interference. I'd like to thank all of our volunteers and field crew, the Texas Comptroller of Public Accounts for funding our work, and KPC and the Warren family for access to the field site. I look forward to answering questions in just a bit.